Hello and welcome to part 10 of the chapter Triangles. We were solving riders. So far we solved 7 riders and 8th one was given for the homework. Hope you have done the homework. So we'll start with the homework first. You can check the solution. Yes, here is the homework. We'll see the figure also. In triangle ABC, AB is equal to AC. AE is perpendicular to BC and D is any point on BC. I remember two hints were given in the homework. One is perpendicular from the perpendicular on the base in isosceles triangle is also the median, that is E is the midpoint. Altitude and median on the base are the same. And second hint was given about AB. We'll see what is asked to prove. AB and AD both the hypotenuse, so there is no much problem to write two statements with AB square and AD square. Let's start the proof. Yeah, so Pythagoras theorem in triangle AEB will give you AB square is equal to AE square plus BE square, and Pythagoras theorem in triangle AED will give you AD square is equal to AE square plus DE square. Now we want AB square minus AD square. So 1 minus 2. So statement 1 minus statement 2 will give you AB square minus AD square is equal to AE square plus BE square minus AE square plus DE square. We'll open the brackets in the next statement. And you can see here AE, that is plus AE square, and minus AE square will get cancelled, and we'll get a little simplified statement here. AB square minus AD square is equal to BE square minus DE square. There is no problem with the left hand side. Now right hand side, it is a product of CD and BD, and we have here BE square minus DE square, subtraction. Now, if you compare this with one identity, that is a square minus b square, so you get a plus b, a minus b, and you get a multiplication sign in the middle. This is one. Second, if you see be minus de, be minus d is bd, which is there on the right hand side. Let's go ahead and apply the identity. A plus b, a minus b. So AB square minus AD square. So second bracket I will see first. B minus D is BD. Now I'll come to the first one. We want there CD. And CD we can get if it is EC plus DE. But we have BE. But BE and EC are equal. BE is equal to EC. In an isosceles triangle, perpendicular on the base bisects the base. So in place of BE, if you put there EC and just add, you will get AB square minus AD square is equal to CD into BD. Very nice rider. This is a perfect rider for the board exam. We solved 8 riders based on Pythagoras theorem. Now we'll go to the other type of riders which are based on BPT and similarity. So let's start. Riders based on BPT and similarity. We'll see the figure. First we'll solve very simple riders. This is S and T are points on sides PR and QR such that angle P is equal to angle RTS. And here you have to prove angle RPQ is equal to RTS. See how the correspondence. When we say RPQ, it is not RST because RTS, because angle P is equal to RTS. We'll see the figure. I have turned the triangle other side, um, left hand to right hand side and right hand side to the left hand side, and the triangle is RTS. Now it is very clear. It's a very simple rider. This is rider based on common angle, and there is angle R is equal to angle R. There is a common angle, and second is given. So just by AA criterion, similarity criterion, we can prove the two triangles are similar. This year, even for this type of rider, there is a scope. This can be asked for 2 marks, or this can be a rider for level 2 mathematics. Let's go to the second rider. Yeah, this is a nice one. In the adjoining figure, DE is parallel to AC and DF is parallel to AE. Now see, DE here, DE is parallel to AC here, and second is DF. DF here is parallel to AE. So we can use here BPT in two different triangles. Let's see what is asked to prove. BF upon FE is equal to BE upon EC. So these ratios which are asked, these are on the same side of the triangle. That means on the other side, the ratio is the same. That is BD upon DA. So that you can equate the two ratios. Let's see, we will go ahead with the BPT straight away. In consider triangle BCA, the total triangle, and in which what is parallel is DE is parallel to AC. So the BE upon EC is equal to BD upon DE. Let's go to the other triangle. Consider triangle BEA. Kindly do the correction there. It is not BFA, BEA. And here we get BF, DF is parallel to AE. So we can apply the BPT. BF upon FE is equal to BD upon DA. Now look at statement 2 and statement 4. The right hand sides are same. So easily can equate the left hand side, and that is what is done in statement 5. BE upon FE is equal to BE upon EC. BF upon FE is equal to BE upon EC, and that is what is asked to prove. Now actually later on, this is also a good rider, but cannot be asked for 3 marks. This can be a 2-mark rider, but the same idea plus another 4-5 steps, we can get a new rider. We'll see that later on in the next video, another rider based on similar idea. This is very simple. I hope this is clear to you. So we can move to the third one. In the adjoining figure, E is a point on the side CB produced of an isosceles triangle ABC with AB is equal to AC. If AD is perpendicular to BC and EF is perpendicular to AC, then let's see what is asked to prove. That is triangle ADB is similar to triangle EFC. Now when you say ADB and EFC, both are right angle triangles. So obvious, the first statement will be uh, each is a right angle, that is ADB and EFC. Now here if you see the look at the triangle ABC, it is isosceles triangle, and in isosceles triangles angles opposite to equal sides are equal. So the two angles are ABC and ACB, they are equal. Now here another very interesting thing is angle ABC or ABD, we can call it, is in one triangle, that is out of which we have considered, and second angle, that is ACB, we'll call it ACE. It is our FCE, which is in the other triangle. Let's go ahead. AB is equal to AC, so that is given. The two triangles, one is ABD and other is ECF. Okay, these are the base angles of isosceles triangle, and they are respectively they lie in triangle ADB and EFC. With this, we can prove the two triangles are similar by AA criteria. So nice rider. Again, this rider can be asked for 2 marks. We'll see the figure. There are two triangles, and there are CD and GH are respectively bisectors, that is angle bisectors of angle, put their angle ACB and angle EGF, such that D and H lie on the sides AB and FE of triangle ABC and triangle EFG respectively. We have to prove triangle AB. If triangle ABC is similar to triangle EFEG, the original triangles are similar, you are asked to prove the ratios are equal. Now we have to see CD. Okay, CD is the bisector, and GH, again that is a bisector. BC is the base, and EG is also the base. Now original triangles are similar, so we have to consider the two triangles which includes bisectors, and the two triangles which includes angle bisectors are, consider triangle BCD and EGH. Only one angle is equal, B and E, because they are the angles of the similar triangles, corresponding angles of the similar triangles, because it is given to us triangle ABC and triangle FEG are similar. Second, again the corresponding angles of similar triangle, that is ACB and FGE. Now if you see, these both are angle bisectors, so instead of angle ABC, we can write there 2 times angle BCD. Same way here, instead of angle FGE, we can write 2 times angle EGH. If 2 gets cancelled, and we get triangle BCD is equal to EGH, and now we have two angles equal, so we can use AA similarity criterion. But you are not asked to prove two triangles are similar. One step ahead, we can see CD from the first triangle corresponds to the name is not come there properly. It is triangle EGH. So it is GH, and second is BC. BC is corresponds to EG. Kindly write their triangle in the fifth step, EGH. So the rider is over. So again, very simple rider. Today we have solved all very simple riders. So next time we'll go for the difficult one. But similar one I'll give for the homework. Similar to the fourth one. Yeah, the fifth one. So instead of angle bisectors there, where you have the medians. If AD and PM are medians of triangles ABC and PQR, where original triangles, that is ABC, is similar to triangle PQR. This is still another way of asking the question. We can initially, you must have seen, asking the two triangles similar. Later on, we saw asking the ratios equal, and this is still further. One step ahead of ratios equal, we cross multiplied. So it will be uh, AB upon PQ and AD upon PM. So you can see which two triangles you should consider. And there we took the angle and angle bisectors were there. Same idea you have to use here with medians. Do this example on your own. That's all for today. See you again. Thank you.